Many of you have undoubtedly heard the word force before. I forced my way through the crowd and may the force be with you. But what does it actually mean? A force is a push, pull, or any action that has the ability to change the motion of an object. For example, if we push this swing or pull this rope, we are applying an invisible force that changes the way these objects move. There are two distinct types of forces: contact forces, like when my foot directly touches this ball, causing it to move in the intended direction, and non-contact forces, like the force that causes the same ball to hit the ground when I let go of it. Force is measured in newtons after Isaac Newton, who decided to investigate gravitational force after an apple fell down on his head while sitting under a tree. More on that later. But for now, we'll share the three fundamental laws that Newton discovered regarding force. Law number 1, the law of inertia. What is it? What does it mean? How does it happen? Well, basically, it means that objects tend to keep doing what they are already doing. If this car is stationary, it stays stationary. But if it's moving at 60 kilometers per hour, it tends to keep moving. That's why to begin moving the car, you must apply more force on the accelerator compared to when the car is already moving and you are trying to maintain a certain speed. This brings us to Newton's second law. Force equals mass times acceleration. Great. What does it mean? All this means is that the greater the mass of the object, the more force required in order to make that object move. And finally, law number 3. For every action, there is an equal and opposite reaction. Take this chair, for example. It's applying a certain amount of force on the ground, which is the action, and the ground is applying the same amount of force back on the chair, only in the opposite direction, which is the reaction. So while there are many types of forces that we experience daily, such as man-made and natural forces, how do these forces affect the behaviour of objects? While we ate apples and pondered this question, we grew increasingly interested in the natural invisible force surrounding us, gravity. It got us wondering how gravity affects life systems on Earth. Specifically, we chose to find answers to how life on Earth relies so heavily on the relationships between the sun, moon, atmosphere, plant, human and animal life. Gravity is the invisible force that pulls us towards the Earth's core. Newton discovered that the attributes of gravity were: the greater the mass of an object, the greater the gravitational pull. He also found that the closer the distance between two objects, the larger the gravitational pull. This is how we can explain how the planets revolve around the sun. So what stops the Earth from falling closer to the sun, you may ask? Gravity, of course. Best we demonstrate. Let's say the very top of this totem tennis pole is the sun. Gravity is the string and the tennis ball is Earth. According to the scientists at Science Line, the Earth is always being pulled towards the sun by gravity. If we hit the tennis ball, it allows us to see that the Earth is actually moving sideways and orbiting the sun. The Earth is not moving fast enough to escape the sun's gravity and leave the solar system, but it is going too fast to be pulled into the sun. Just as the sun and Earth have a gravitational force, so too does the Earth to the moon. Here is a fun fact. The moon's gravitational pull may have been key to making the Earth a livable planet by moderating the degree of wobble in the Earth's axial tilt. This may have led to a relatively stable climate over billions of years where life could flourish. So what does the moon's gravitational force have to do with life on Earth? It has an impact on sea levels known as tides. The moon's gravitational force is strong enough to pull ocean water toward it, creating bulging. This is known as a high tide and occurs on the side of the Earth that the moon is closest to and also the side of the Earth furthest from the moon. Tides impact floating plants and animals to ride the tidal currents between breeding areas and deeper waters. They help to remove pollutants and circulate nutrients that sustain life beneath the water. The tides produce a predictable and habitable climate which allows life to flourish. Tides are not the only thing that play a part in Earth's weather. Gravity creates an atmosphere or vacuum here on Earth by trapping air in the atmosphere. It also helps create weather systems which are integral for balancing our temperatures here on Earth. Dependent on the light from the sun and the weather, plant life also responds directly to Earth's gravitational attraction. Plant roots grow in a downwards direction known as gravitropism. To prove this phenomenon, we found an experiment conducted by Miss Wolf's 7th grade students with corn seeds. They were able to conclude that despite the seeds being deprived of light and each seed facing a different direction, the force of gravity alone was powerful enough for the root structure to be consistently pulled downwards. Finally, what are the effects of gravity on human and animal life? We are born into gravity and our bodies are built to function under its force, but it does have a profound effect on the body. Our findings are not exhaustive, but some include compression of the spine. The downward force of gravity causes sponge-like discs in between the vertebrae to lose moisture throughout the day. When we sleep, the moisture returns to the disc overnight, but not 100%. This adds up over a lifetime, and a person can lose between half an inch to 2 inches in height. Muscle mass develops under gravity to help carry our bodies, allowing us to move around. As we grow older and muscle mass decreases with inactivity, we lose the ability to move as easily. Our sense of balance has developed to work against the effects of gravity to keep us upright. Our circulatory systems can be affected by gravity as we age, as our bodies become less efficient at pumping blood around the body freely. This can cause varicose veins, swollen limbs, and a weaker cardiovascular system. Now use your imagination to try and visualise what Earth would be like without gravity. If your pondering takes you to a place of weightlessness where you can float around all day without a care in the world, then you are not alone. We know that humans can survive without the force of gravity, as astronauts do it all the time. However, losing gravity isn't actually as pleasant as you would first assume. Try and imagine yourself as a rapidly moving tumbleweed rolling madly around, but not just you. Every person, animal, car, building, house and tree as well. Now you will begin to get a sense of what life would actually be like. As you all know, the Earth is constantly spinning, and therefore without gravity holding us down, we would be tumbling about like pinballs. Of course, this drastic change in air pressure would result in the eruption of our inner ears, and without gravity supporting our atmosphere, there would be no oxygen for us to breathe. The tidal effects from the moon would be changing so drastically, causing earthquakes and tsunamis, and pieces of the Earth would fly off as a result of the Earth expanding and becoming less dense. Think of the film The Day After Tomorrow, only 10 times worse. There is evidence to support that we would develop quite differently if that were to be the case. We investigated the effect of gravity fields experienced while on a Mars mission, a 6-month trek between planets completely free from gravity. While on Mars, astronauts work in approximately 1/3 of Earth's gravity, and the physical consequences on the body are quite severe. According to NASA, the transition between gravitational fields would affect your spatial orientation, hand-eye coordination, balance, locomotion, and you're also likely to experience motion sickness. NASA also concluded that without gravity doing its job, your bones would lose minerals and density rapidly, about 1% per month. By comparison, the rate of bone loss for elderly men and women on Earth is from 1% to 1.5% per year. Unsurprisingly, the fluids in your body would float upwards into your head without gravity keeping them down, generating pressure on your eyes and causing vision problems. You'd also need to be hitting the gym a lot more regularly due to a loss of muscle strength and endurance. So, long story short, we love gravity, but do all species need gravity like we do? According to researchers from National Geographic in 2010, plants don't actually rely on gravity in order to flourish. A study conducted at the International Space Station with flowers growing whilst orbiting 350 kilometres above Earth concluded that plant life does not actually require gravity at all, and the seeds in the space station were still able to sprout roots growing downwards to obtain nutrients and water, exactly like they do in your garden. By this point, we hope you are feeling as inspired as we are in the fascinating force that is gravity. Of course, learning about all of this only encouraged our research further into the training process of an astronaut taking the trek into space. You know that feeling you get when you free fall after jumping off cliff rocks into crystal clear ocean blue waters beneath you? Until you hit the water, you are experiencing the feeling of weightlessness. This is the same feeling experienced by astronauts when sent on missions to outer space, where the force of gravity is minimal to non-existent. We got thinking, how does NASA possibly prepare its employees for these conditions when gravity is so prominent here on Earth? And then we discovered this. Astronauts preparing for spacewalks test their skills in the Virtual Reality Lab, which immerses them in a computer-generated microgravity environment. Additionally, with the Neutral Buoyancy Lab in the US exists the world's largest indoor pool. This pool holds 6.2 million gallons of water and is more than 200 feet long and 40 feet deep. Deep within the pool, a weightless environment allows astronauts to train for up to 10 hours on spacewalks in full-sized replicas of space station modules. Besides training in microgravity, astronauts must also engage in targeted exercise, both on Earth and in space, in order to minimise the effect of microgravity on their bodies. Scientists from NASA aren't yet sure how gravity signals the body to keep bones and muscles strong. They do know that somehow gravity is converted from a mechanical signal to a chemical signal, and they know a lot about these chemical signals, but the mechanical signals remain a mystery. If we are able to isolate the mechanical signal that makes strong bones and muscles here on Earth, could we create a pill that mimics this to give to astronauts so their bodies degenerate less in space and better readjust when they return to Earth? Perhaps such a pill can be given to the elderly or those impacted by injury or disability who also experience fragile bones and muscle loss, ultimately increasing quality of life and life expectancy. Research has a long way to go, and there are so many wonderful questions. And the answers? Well, they're waiting for us, up there in space, where the absence of weight reminds us that gravity isn't all bad. Through our investigations, we have been able to see that gravity really is a guiding force that has created the conditions we need here to survive on Earth. The sun, moon and atmosphere all play important roles in creating a livable planet for plant, animal and human life to exist. Plants, animals and humans all take their cues from gravity and have bodies that function accordingly under the weight of gravity. Investigations into space have allowed us to see that life is possible in microgravity, but somewhat inhibited under these extreme conditions, and its long-term effects are still yet to be discovered. By applying what we know about life in microgravity and through our investigations into NASA's simulated microgravity training here on Earth, we have been able to envision new ways to apply microgravity to help improve our longevity and quality of life here on Earth.